Thank you for your lecture. I'm Haruka Shirahata, major in chemical engineering. And I would like to hear your opinion about renewable energy. And I think in the US, the renewable energy is overtaken by shale gas. But I think it is important to make renewable energy common in the world to ensure the diversity supply of energy. And in the world, for example, in Germany or Denmark, there is a trend that citizens themselves use renewable energy. And so, but I think it is also important to make regulation about renewable energy. So which way, approach by government or approach by citizens is effective to make renewable energy common in the world?
Yeah, well, it's a great question, and we have a saying in Washington, bottom line up front. Bottom line up front, you need both. And just to make one small statistic to explain why that's so, private capital markets move more money in a day than governments move in a year. And you're talking about trillions and trillions and trillions of dollars of investment that are required, okay? So we're pretty proud of what we've done so far in terms of renewable. President Obama asked for us to double the installed base of wind and solar from 2008 to 2012, and we did. And he's now, in the Climate Action Plan, asked us to double yet again by 2020. Point one. Point two, wind alone. Onshore wind is almost, in areas where there's strong wind, competitive with conventional power sources. So that means, and I admit it's assisted by the production tax credit, in 2012, 43% of the new installed power that went onto the grid in the United States was from wind. Okay? And we're up to 60,000 megawatts, 60 gigawatts of wind. That's a lot of wind. Solar, a little less, it's behind. What are we doing in solar? We're not going with a feed-in tariff route. We don't think that subsidizes inefficiency. We're trying to bring down costs through investment in advanced technologies, our so-called Sunshot program. But I invite you to think broader than just renewable. We think clean energy. And in that respect, we bring in, obviously, well, you can think of hydro as one or the other, and it obviously brings in nuclear energy. That's an important part of the equation, and it brings in efficiency. The key here is, it's true. There's no getting around the fact that when natural gas is $13, it makes a big difference compared to $2 or $3 or $4 gas in terms of the competitiveness of some of these new technologies. But what we need to do is to come up with mechanisms to help capture some of the economic benefits that are actually there for renewables. I'll give you just one short example. I don't want to stop other people from asking questions. But as I mentioned, through the loan guarantee program, we've got about the biggest wind farm in the world, several of the biggest solar PV projects, solar concentrated projects, and so forth. So now, having deployed on the order of, we have $90 billion of assets getting built that are throwing off electricity. They're getting 20, 25-year power purchasing agreements. Those have zero commodity risk as long as the sun shines and the wind blows. There's zero construction risk because they're already built at this point. And there's predictable cash flow. So now you've got a financeable asset. So now we've got to figure out ways to persuade or to show private capital that these are attractive investments to make. And it's actually happening. We could talk about this for hours. You can't, but I could. And those are the kinds of things that we need to do to make clean energy solutions ever more present in our overall energy mix.
Okay, thank you. Okay, and another question. Yes, please.
Thank you. Thank you very much for the talk. It was really insightful. I have a question about nuclear energy technology. A third generation reactor.
Excuse me, could you have more distance?
Okay, sorry.
You can keep distance.
Third generation reactor.
Right.
I've heard that third and fourth generation reactor could be a really useful tool to economize energy and a third generator also. And I would like to know what were the concrete action done by American government or company to develop that kind of reactor.
Yeah. So the U.S. government is focused on a couple of things. As you know, we're building the large traditional Gen 3 plus reactors now, including through the support of the Loan Guarantee Program. You probably know that getting the, for example, the AP1000 reactor to a state of being licensable and deployable around the world was benefited greatly by the NP 2010 project, the U.S. Department of Energy, which defrayed a lot of the costs of the licensing of the designs. So in the same spirit, this is to your question, we now are investing in the co-financing effectively of the reactor design processes for small modular reactors, which a lot of people have a lot of interest in as the next generation. We have approved a couple of these projects through a competitive peer review process. Those are now going into the design work that will ultimately lead, we hope, to NRC approval of these designs. And I can tell you, because I've talked to people around the world, there's a lot of interest in a lot of countries in getting that kind of reactor approved with the seal of approval in terms of safety from the Nuclear Regulatory Commission. So that's where we're focusing a lot of our attention. And there was another question right near you there. Yes, sir.
Okay, yes.
Thank you very much for your speech. I'm a student of electrical engineering, and I want to ask you a question about that. Well, just as you mentioned, 10 days ago, Environmental Protection Agency announced the targets to cut carbon emission from existing power plants. So it's a significant step towards cutting greenhouse gas. And my question is that what's the next for United States in order to obtain the leadership in the climate change?
I'm sorry, could you restate that last part of the question? What's
yes, I want to ask what's the next for United States?
What's next?
Yes.
What's next? Gee, well, I mean, I think what's next is continued investment in new technologies. There's a lot of really, really exciting things happening out there, and maybe some of you are already working in them. So let me put it in a broader term. I think what's next is watching the continued transformation of our economy in the direction of reduced carbon emissions. That's the secular trend that I predict are going to observe, and as the President has said, whoever leads the clean energy revolution will lead the world in terms of economic prosperity, because there are new industries, there are new businesses out there to be built. Now, we don't know exactly which technology would flourish. And the approach that the U.S. Department of Energy has taken is a portfolio approach. So, for example, our loan guarantee program has an element called the Advanced Technology and Vehicle Manufacturing Program. And this looked at the whole fleet of American vehicles out there, both those that exist and those that are on the drawing board. And we gave a $5.9 billion loan guarantee to Ford Motor Company to improve the CO2 performance and the overall efficiency of its full fleet of vehicles. Why? Because even a small reduction in carbon on a big base of vehicles could make a big difference in our overall carbon footprint. At the same time, we invested at the other end in a pure electric vehicle no one had ever heard of at the time, called Tesla, which has turned out to be a phenomenal success, and they prepaid their loan early. So just take such an important part of the carbon equation as the transportation fleet, because oil is such a concentrated source of energy, it is uniquely suited to mobile uses. Not so good for stationary uses, and obviously very bad in terms of the climate effect. So what's going to happen? If we want to get our arms around climate change, we're going to have to get our arms around the transportation fleet. So what does that mean? That means maybe it's going to be Tesla. Maybe you're going to see the electrification of the fleet. The United States has a program called EV, Electrical Vehicle Everywhere, and we're working with other countries. We're working with Japan. We're working with China to try to make it possible for every country to have compatible electric vehicle systems so you can plug in your cars and so on and create a big market for these electric vehicles. On the other hand, there's a lot of interest in natural gas fueled vehicles too, which would also reduce carbon a lot. And of course, when you look at the life cycle effect, you can't just look at the automobile, but if you charge up your electric vehicle with a coal-fired power plant, it doesn't count as the same kind of benefit in climate change terms as if you go to a natural gas vehicle and cut in half your carbon emissions. So we have both efforts in the area of compressed natural gas vehicles and LNG vehicles for big trucks. So that's another area. Look at battery storage. Please look at the website. You guys are all young men and women in engineering. You're all working in these fascinating areas. Take a look at the website of our Advanced Research Projects Agency for Energy, ARPA-E, and you will see the most exciting set of technologies being pursued, flow batteries, advanced vehicles, compressed natural gas options to have better sorbent technology, carbon capture and so forth, and somewhere in there you will find, we just don't know which one it is or which ones they are, the solutions to tomorrow's energy problems.
Thank you. Yes, please.
Hello, I'm a student in the...
Excuse me, could you keep
sorry.
the distance?
I'm a student
There's a lot of
in the
feedback, yeah.
nuclear engineering department, and I just started studying non-proliferation issues. My question is, well, I recently learned that your country is considering downblending and disposal of weapons-grade plutonium using non-radioactive diluting material as an option. And, well, in Japan, I have this impression that that the direct disposal of spent fuel is sort of unacceptable because of proliferation issues. That was the impression I had as a student learning non-proliferation issues in Japan. And I'd like to, and so I'm confused, and I'd like to hear your opinion, a brief opinion on Japan considering the direct disposal of spent fuel and aborting its reprocessing missions.
It's a great question. Next time you should choose a difficult subject, right? So look, let me make a brief comment. This is an incredibly important subject. When the Soviet Union broke apart, I happened to be working at the National Security Council, and we were immediately faced by the prospect of one nuclear weapon state turning into 4. And so we had to deal with Ukraine and Kazakhstan and Belarus. And we were also faced with what we call the problem of the brain drain, which is all these really smart people who knew how to make nuclear weapons having nothing to do anymore, and how to deal with that. And we're also dealing with the question of fissile materials, which is what you're getting at. Now, pretty soon we realized that for highly enriched uranium, there was what an economist would call an elegant solution. Why? Because, first of all, in terms of vulnerability to terrorism or weapons use, once you take highly enriched uranium and blend it down to low enriched uranium, it's very hard and very expensive to get it back into any kind of weapons form. So it gets real safe real quick. That's the first bit of good news. The second bit of good news is once it's diluted, there's actually a commercial market for the material. And so, and I had the privilege to be on the team that negotiated a purchase of 500 metric tons of highly enriched uranium from Russia. That's 20,000 weapons worth. and we saw it, and I never thought I'd see the end of it, because it was a 20-year deal to blend it down for commercial reactor fuel. So just think of it this way. The United States, 20% of our electricity comes from nuclear, and for 20 years, half of that was fueled by this material out of Russia. So for 20 years, 1 in every 10 American light bulbs was lit by material that used to be in the form of a warhead targeting American cities. That's not bad. Translates to 3 weapons a day. And it ended in December, the last shipment. Plutonium, different story. And that's why your question is a good one. We knew, number one, because unlike U-235 and U-238, plutonium is chemically distinct from other elements with which it is mixed, that even if you diluted it, you could reseparate the plutonium. That's a problem. We also noticed there was no market. In fact, we couldn't even agree if it was an asset or a liability, okay? So whenever we have a hard problem, we give it to the National Academy of Sciences, and in 1994 they came up with a study, and it actually identified a number of approaches. And immobilization was one of the legitimate approaches, and it still is, even today. It has its challenges. There was a time, a pretty long period of time, when people used to talk about spent fuel being self-protecting. Of course, over time, that self-protection fades away. So that's why you do have to think about some kind of more discrete, separated disposal mechanism. But there were other mechanisms that were also considered. Obviously, converting that material into mixed oxide fuel and irradiating it again was another approach. To be candid, this remains a tough problem even today. Why? Because plutonium remains different from uranium, and because the vulnerability from a proliferation standpoint remains a serious problem, and because even today, to make a business case that closes for use of plutonium in a civil fuel cycle is a hard thing to do. And you will notice that the United States abandoned that in the mid-1970s on economic grounds. So you ask a great question. I wish it had an easy answer. It doesn't. And I can tell you this, I've worked a lot on that over the years, maybe you can tell, and I'm going to keep working on it and see if we can get some answers.
Okay, so thank you very much. I think there are still many questions, but unfortunately, because of the time limitation, and Mr. Poneman will have to leave soon. So I would like to finish these questions. And before we close this talk, so I would like to ask the Dr. Professor Matsumoto, he will have some souvenir to you from the School of Engineering.
And we really enjoyed you encouraged our students so much.
Yeah.
Thank
Good.
you.
Well, thank you very much. And
this is just a souvenir for you.
Thank you very much.
Yeah, from our
it's an honor to be here. Okay.
Thank
All
you.
right. Keep studying. Thank you. One more question?
Yeah, no, from the School of Engineering.
Thank you.
Yeah,
Thank you. All right. Thank you.